go. Okay. So yesterday we talked about slope and how that's the slope-intercept form, how you're going to be able to find slope from any data set points. Now here's one way that I wrote it. I wrote it y, the second y minus the first y, over the second x minus the first x. Now that's better written as just being delta y over delta x. Algebraically, that term delta, which is a triangle, it's a Greek symbol, that means change in. So if we have 2 points, I'm going to try to use as much color coding as possible to show you where I'm coming from on these. So write an equation that goes through a line of 4, 2 and 8, 14. I'm going to identify what my y values are so I can keep that going. And I'm going to have change in y over change in x. Delta y over delta x is equal to 14 minus 2 and 8 minus 4. So that is how I'm going to find the slope of that linear function by just 2 plot points. So it's going from what is the, how rate does that go rise versus run between those 2 plot points. And I'm going to get 12 over 4, which is 3. 12 over 4, which is 3. But they're asking us to find an equation. And we need to find everything from y equals mx plus b. So I just found, let's do a different color. I just found what my slope is as being 3. But I need to find everything in there. So I can use any of these plot points to use as my y value and my x value. Oh, one other thing I want to add. If you did that backwards as 2 minus 14, and if you did it 4 minus 8, you would still get 3, because it'd be a negative over a negative, which is a positive. But if you just have to make sure that you are using the same coordinates as a relation as it would be, that you're not accidentally doing like 14 minus 2, and then you're doing 4 minus 8. That will not get you the right slope. So now I know that I have my y value. I have 3 as my slope. So now I have y equals 3x plus b. I need to solve for b. I can substitute in a value. Here's my x. There's my y. So I'm going to substitute those 2 in. 2 is equal to 3, 4 plus b. Because I know that that's a plotted point on the graph. So I can substitute that in there. I'm trying to find what is the y-intercept so I can complete the function. So I'm just going to shift over here. So now I have 2 is equal to 12 plus b. And I can solve for 12 plus b. That's from 7th grade. Minus 12, minus 12. So now I have negative 10 equals b. So what we're doing is we're just finding little pieces and applying, like, well, okay, here's a y value. I can plug that in so I can find one of the other slope or intercepts. I already used purple just then. So since I know my slope, now I know my intercept, my function is going to be y equals 3x plus a negative 10. And that applies to anything. I could plug in 4 and 2 in there, and that would work. I could plug in 8 and 4 in there, and that would work as well. Did I do that last period? No, I didn't. So this would be, and that could also be written as this, but that's not how it is on the test. Some of your questions might be like that, though. That's the same thing as what's circled and what's below it. Because if you add a negative, it's the same thing as subtracting. So that's how the second half of your homework is. And then we're going to do another equation. So this one, we have 3 different coordinates that we can choose from. I'm still going to do change in y over change in x. I'm going to take the prettier one because it's a more even number, a smaller number, I guess. 64.25 minus 50.5. So there's my change in y. My change in x is nice and pretty with 7 minus 2. So the delta y over delta x, that's the same thing as the slope, which is m. That's why I wrote an m on that one. So I do 64 minus 50.5, and I get 13.75 over 5. And I would get 2.75. 2.75. So now I have found my slope. Part 1 of that is done. So just for organization reasons, I'm going to just do a little dotted line right there. So now that we found our slope, now we're going to try to find the slope intercept. So we are going to plug in any of these sets of numbers for the values of x and y to find what b is. So remember, y equals mx plus b. So my y value is 50.5. This is coming from right here. And x is going to be right there. Y equals m, we already found that, is 2.75. X, the value is 2. Plus, I don't know what b is. And to write every step, 2.75 times 2 is 5.5. I have my b still left over there. B likes to practice social distancing by being by itself, so I'm going to subtract 5.5 from both sides. Now I found my b. Now I found b. So now I just need to do the linear equation of y equals 2.75 for any value of x plus 45. And the reason why we go back to having that slope-intercept form is because that's for any line or any plotted point on that graph line, this holds true. So that ties in yesterday and the day before. I think I like the way I'm laying these up better. So here's the easier part of what your homework is, because this part right here that we just did, that's the more difficult part. The easier part is just finding slope, and that's what the first couple of these examples are with the new stuff-ish. An electrician charges a set fee for every house call and then charges an hourly rate depending on how long the job takes. So this is like your homework from Monday, Thursday. Let C represent the total cost of the visit. So whenever you say a total cost, that's the Y output. So this is just like Y. That C is just like Y. This T is just like the value of X. Let C represent the total cost of the visit. The electrician spends T hours at the house working. The table below has a select values of showing the linear relationship between T and C. Determine the hourly rate charged. Now, whenever they're asking you what an hourly rate is, or whenever they're asking you something that's being multiplied by something else, all they want is the slope. I wasted a lot of time when I first started working on these notes the other day to prepare for it. And I try to figure it out by myself to make sure that it's going to be asked the way that it is. Then I'll look at Delta Math, and then if I can track down one of the other teachers, I'll ask them. But so I just need to find any delta y over delta x. So I'm going to use the nice pretty blue one, 700 minus 245. Then I have 9 minus 2. 9 minus 2. What's the question?
I have a question.
Sure.
Are the top two numbers for delta Y, can you choose any of them in like the C column?
Good question. Yes, you can choose any which one you want to, because let me turn myself down. I can hear myself. Any value will work for that, because no matter where it is on a line, each plot point is always going to have the same slope. I like to choose, like we could have done this one, but I try to avoid decimals anyway if I can, because it's just another thing that you have to type into the calculator. So we have 700 minus 245, just to make sure I don't make a silly error, 455 divided by 7. And if you look at the notes that I had posted in the notes thing, I use a different set of points to find slope, and it still comes out to be $65 as the hourly rate. The hourly rate of $65. So whenever they're talking like an hourly or a daily or something like that, it's going to be, you're going to have a, you're looking for the slope. At the end of the snowstorm, Mia saw there was a lot of snow on her front lawn. The temperature increased and the snow began to melt at a steady rate. So right here, there's our clue. It melts at a steady rate. That's our clue that we're going to be trying to find slope. Let S represent the depth of the snow. And remember, your output is going to be a capital number. That's why I'm putting X and Y right here. So I know when I'm dealing with Y equals mx plus b, slope intercept form, I don't make a silly error and have different values for x, t, because in this situation, they're asking for S is equal to mt plus b. That's how that applies to that. Whereas slope is still m and b is still the y-intercept. The table below has select values showing the linear relationship between t and s. Determine the rate at which the snow is melting per hour. Now, it's asking us how much is it melting an hour. So you would think, well, we should have a negative slope. Let's find out. So I have my change in y, 4.5 minus 10.5. Change in x, 7 minus 3. That comes out to be negative 6 over 4, which simplifies to negative 1.5. So there's our negative slope. There's our negative slope, because when snow melts, it wouldn't be a positive slope. But the question is asking us, how much is the snow melting? If the snow is melting at negative 1.5 inches an hour, we wouldn't necessarily need to do a negative in our solution with this. It'll still be like that for the slope, but you could write it like this. The snow is melting at 1.5 inches an hour. Is it an hour? Yeah, an hour. Because by saying melting, saying the word melting, obviously you know if something is melting, it's becoming reduction in size, especially since we know what snow is. Okay, I mean, you guys can find that easily. Any questions so far? Not yet? Okay. All right, this is, okay. An electrician charges a set fee for every house call. So a set fee for every house call, that's gonna be my B. Whoa. That's gonna be my B. Every house call and then charges an hourly rate. Your hourly rate is gonna be your slope on how long the job takes. Let C represent the total cost of the visit and T the electrician spends in time, T hours at the house working. The table below has selected values showing the linear relationship between T and C. So if the electrician was there for 2.5 hours, it would cost you $242.50. If they were there for 4, it would cost $450. 7 is $580. And if that sounds steep, that's not too far off of what actually happens. So I'm trying to find, determine the set fee. Okay, the set fee, we're looking for the slope intercept. So now this is just like the second example. On this side of it, I'm gonna do, where are we? There we go. On this side, I'm gonna find my slope. I'm gonna take I'll just take the green, the blue ones. 580 minus 355 over the change in X. So here's how I know it's Y, here's know it's X, because the outcome is Y, the output is Y, and the output here is a capital C. So this goes to, my slope is 225 over 3, which is equal to 75. So my slope equals 75. So now I know how much he charges per hour. Oops. Now I know how much he charges per hour. Now I need to find what the set fee is. So here's my slope. Let's do red. So I'm looking for Y equals 75 X plus B. I don't know where on the plot I'm going to be going right away. So I have X and Y. I'm going to go ahead and do this one because it's a small number. Once again, you can use any of those plot points that you want to when you're trying to find the Y-intercept. So I'm going to use 355 equals 75 times 4 plus B. So now I have all numbers in just one variable. To do every step for demonstrative reasons, now I have 350, well, sorry, just 300. 300 plus B. In order to get the variable by itself, subtract 300 from both sides, subtract 300 from both sides. So I got 55 equals B. So that tells me the set fee, just for going there, is $55. Because no matter what, if he steps into your house and goes, I can't help you, that initial fee of $50 is already theirs. And this will be, yeah, this will be the last one that we do. Because number 7 is just like number 6 with different numbers. Yeah, that works. Zoe bought a plant and planted it in the pot near a window in her house. Let H represent the height of the plant in inches, T months since Zoe bought the plant. The table below has set values showing the linear relationship between T and H. Determine the initial height of the plant when it was purchased. So we are looking for the initial height when the plant is purchased. It didn't matter how long it's been since then. It's just the initial, so we are looking for B. We are looking for the Y-intercept. So we are looking for Y-intercept. So in order to do that, once again, we have to find the slope and then enter some of those values. So the slope for an ugly m is change in y. Let's do this one, it's pretty, because I don't like decimals, they take too long. But it doesn't matter which one you did, as long as you're just having the ones that are green and the ones that are blue. And 9 minus 4. So now we have m equals to 10 over 2.5. And that happens 0.4 times. Oh, wait, 25. What? What did I do there? Just 5. Sorry, I'm looking at wrong examples here. 20 over 5. There we go. And that comes out to be 4. Did I copy something down wrong? Oh, I'm doing a different one. Good. Okay, here's another example of you can choose any of those points. I used a different one last period. So it comes out to be 20. Yeah, 20 divided by, but that's 4. What did I do here? 20, 9 minus 4 is 5. 10, 2.5, 0.4. Interesting. Okay. Because 5. So it would be 10. 2.5. 10 divided by 2.5 is 4. 4. 4. Okay, I was off by a decimal in last period. Okay, so now I have found my slope is 4. So I need to plug it into h is equal to 4x plus b. So I can substitute any h in there. I can do 25 equals 4 times 4 plus b. That comes out to be 25 equals 16 plus b minus 16 minus 16. Yeah. So 9 equals b. In the notes, if you guys use that as a reference, I might have to undo those, but I'll have the correct version because I made an error on that one. Yep, I had the decimal in the wrong place. So the initial height was Zoe's plant was 9 inches tall. So the initial height was 9 inches tall because it grows at 4 inches a month. And in the notes, I just accidentally had a decimal, a phantom decimal in there, and that's why it comes out to be a smaller number for the initial height. But stop recording.